My topic is all about approximation algorithm. Approximation algorithm are used for solving NP hard problems where finding the exact optimal solution is impractical. They provide near optimal solution. The goal is to achieve a solution close to the optimal value within a granted bound. So, approximation algorithm are used when a problem is too hard or it takes too long to find the perfect answer. So instead, we're finding answer that is close enough to the best one, and we can find it quickly. Example, imagine you are delivering package to many cities and want the shortest route like traveling salesman problem. Finding a perfect route might take years of a computer. So an approximation algorithm are finds route that is almost short but is just a few seconds. Importance of approximation algorithm. Real world problem like traveling salesman problem, TSP, and set cover are computationally expensive. Approximation algorithm allow us to find feasible solution within a reasonable time frame. They are essential in optimization, scheduling, logistics, and network design. So importance of approximation algorithm. These algorithms are very important in real life because many problems like delivery, routes, scheduling, or network connection are too big to solve exactly. Approximation algorithm help us get good and answer fast. Example, in network design, companies use approximation algorithm to connect cities with cables cheaply. Maybe not absolute cheapest, but very close to it and found quickly. In short, approximation algorithm pangitaon ang pinakaduol o best nga solution. Kung atong problem mo takes pa og years or century para ma-solve. Dili man siya mga tag-exact answer, but enough na siya or best answer na siya, duol na siya.
Good day everyone. Today I am going to present my report about approximation techniques. Approximation techniques are general strategies used to design algorithms that give near optimal solution for NP-hard problems. When finding the exact solution is too time-consuming. There are 4 types of approximation technique. First, greedy algorithms. Second, linear programming relaxation, randomized algorithms, and primal dual method. So, greedy algorithms. This method works like how we make quick, practical decisions in real life. We solve a problem step by step, always choosing what seems best at the moment. It's called greedy because it grabs the best immediate option without worrying about the future. Linear programming relaxation. Sometimes a problem has integer or whole number limits, like you can only pick whole items, but to make it easy, we first pretend we can pick fraction of items. That's called relaxing the problem. After solving it, we round off those fractions back into whole numbers. Randomized algorithms. Instead of following one strict plan, this method tries using random choices to see what works best. And the last is primal dual method. This method solves a problem by looking at it from 2 sides. The original called primal and its opposite version called dual. By balancing both, we can find a good near optimal answer. That's all.
So this is my example of randomized algorithm. Randomized algorithm sa nakita ni natin. Na-example din sa nasa example din. Ato siya ang ikat kung ato siya o 1. Ato siya ikat o 1 na. Bali siya ang result niya ikat siya o 1 na. Next is ato lang siya ikat muna siya sa boss 1/4 ko siya. 1/4. Pag umana ato lang ikat muna niya ang result niya sa boss. Ang iyang part muli ang dili sa tawag sa 1/1.
My topic is QD seat cover and greedy approach. So, QD seat cover given the universe U of elements is AG1, 2, 3, 4, 5. A collection of subsets H-1, H-2, SM of U. So, ang goal niya is select the fewest possible subsets so that their union covers all elements in U. This is an NP-hard problem, meaning we can find the optimal solution efficiently for large inputs, but we can approximate it using a greedy algorithm. So, that's a greedy approach. Number 1, start with an empty set of chosen subsets. Number 2, at 6 steps, pick the subsets that covers the largest number of uncovered elements. Number 3, and that subsets to the solution. Therefore, mark those elements as covered. Number 5, repeat until all elements in U are covered.
This is example of cover set. Here is U 1 and 2 and 3. Set 1, set 2 and set 3. Cover set 1 covers 1 and 2 and set 2 covers 2 and 3 and set 3 covers 1 and 3. Element 1 and 2 are covered, so we need into 3. Either 2 or 3. 2 or 3 will cover element of 3. So let's pick 2. Because the set covers involve finding the smallest collection of the sequence that when combined include all elements given in the universe.
Trouble salesman problem approximation. ESP approximation algorithm. These are techniques used to quickly find near optimal solution for the triangle conversions of ESP. One is the metric test, triangle inequality rules, and 2 the metric triangle inequality main approximation techniques for the metric version. 1. Near neighbor heuristic simple approximation. Start from any city, repeatedly visit the nearest unvisited city until all cities are visited, then return to start. Step-by-step process of nearest neighbor heuristic is 1. Pick a random starting city. 2. From the current city, go to the nearest unvisited city. 3. Repeat until all cities are visited. 4. Return from the starting point.
So this is the example of nearest neighbor heuristic. So our starting point is the letter A, and the nearest unvisited city is letter B, which is 10. Next nearest is the letter D, which is 25. You might be wondering anong dili ang letter A nga 10 man siya. It is because we already visited the letter A city. Next is C, which is 30. Then after, balik na ka sa letter A kung asa ka or asa imo ang starting point.
Good day. Let's recap what is minimum spanning tree. Imagine if you have cities connected with roads of different distances. The MST find the cheapest set of roads that still connect every city. In short term, MST or minimum spanning tree is cheapest set of roads that still connect every city. There are two methods used in minimum spanning tree by getting the shortest path. The first is classical algorithm, and the second is Prim's algorithm. Classical algorithm is pick smallest edge as long as it doesn't make a loop, while Prim's algorithm start from one point and keep growing the tree and by choosing the nearest neighbor.
Number 3 is the Christophilus algorithm. Improves an industry method using perfect matching and odd degrees of vertices. Algorithm 1. Compute MST of the graph. 2. Identify all vertices with odd degree. 3. Find a minimum weight perfect matching on those vertices. 4. Combine edges of MST plus matching to form an Eulerian circuit. 5. Convert to Hamiltonian to whereby shortcutting repeated vertices.
Advantages of approximation algorithm. First is efficiency for large-scale problems. Provide performance guarantees. Often simpler than exact algorithm. Useful for real-time system where two constraints matter. Limitations. Do not always provide exact optimal solutions. Approximation ratio may still be large for some problems. Not all NP-hard problems have good approximation algorithms. In conclusion, approximation algorithms are vital tools in handling NP-hard problems. Grading method and TSP approximations provide efficient, near-optimal results. Continuous research aims to improve accuracy and efficiency.